topic this morning is electronic configuration, the shell representation. Shell electronic configuration is one topic I find very interesting in chemistry. In our last video, when we discussed the structure of atom, according to Bohr and Rutherford, this is the structure of atom. Atom contains three constituents: proton, neutron, and electrons. Then proton and neutron are found in the nucleus, we already know, while electrons are found outside the nucleus. These electrons revolve around the nucleus just like the Earth and other planets revolve around the sun. These electrons are distributed in a part called quantum shell. So this circular part is called quantum shell, or normally shell. Okay? But you would now ask, are these electrons distributed randomly, or is there any certain pattern of arrangement? Yes, there is a certain pattern of arrangement of electrons around the nucleus. And this arrangement of electrons, the arrangement of electrons around the nucleus of an atom is what we call electronic configuration. Electronic configuration is the arrangement of electrons around the nucleus of an atom. If you look at the structure below, let's say this is the shell structure of an atom. We have the first shell, second shell, third shell, fourth shell, and so on. This is the nucleus. The blue dot is the nucleus that contains proton and nucleus. Then this is the first shell. The first shell is called K shell, or shell 1. This means the lowest energy level. The first shell with N1 is called the K shell, and it has the lowest energy level. So this is shell 1. The second shell is shell 2, or L shell. The third shell is shell 3, or M shell. The fourth shell is shell 4, or N shell. We have fifth shell and so on, depending on the atom you want to draw. I want you to note the first shell has N1. That's principal number is 1. Principal quantum number is 1. And it has the lowest energy. It has lower energy, then followed by this. So from 4 you have highest, high, low, and lowest. Okay? So in arranging electrons around the nucleus, we say that we follow a certain pattern. Then, what is that pattern? There are rules guiding this pattern of arrangement of electrons. There are rules guiding the way electrons are arranged, and this is called Bohr and Bury scheme because it was proposed by Bohr and Bury, two scientists. The first rule is the 2n square rule. The first one says the maximum number of electrons in a particular shell is given by 2n squared. Second rule, electrons are not accommodated in a given shell unless the inner shells are filled. 3. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Let's start from the first one. We said that the first shell is called K shell, or 1, the energy level 1. N means the energy level. And the maximum number of electrons you can find in the energy level 1, the first shell, is represented by 2n square rule. So in the first shell, N is 1, right? The first shell, N is 1. So the maximum number of electrons that can be accommodated in the first shell is greater than 2n squared, which is 2 times n is 1. So we have 1 square equals to 2. 2n squared. 2 times 1 square. 1 times 1 is 1 times 2 is equals to 2. So the maximum number of electrons that can be taken in the first shell is 2. Then, in the second shell, N is 2. That's energy level 2. The maximum number is 2 times 2 squared, because N is 2. which will give you 2 times 2, 4, times 2, 8. Then, M shell, the third shell, N is 3. So, we have 2 times 3 squared. 3 squared is 3 times 3, not 3 times 2 or 3 plus 2. So, 3 squared, 3 times 3, which is 9, times 2, 18. Then, N shell, we have 2 times 4 squared, which will give you 32, and so on. So, if you look at this now, you will know that, in summary, the maximum number of electrons that can be contained in the first shell, which is K shell, is 2 electrons. L shell is 8 electrons maximum. M shell is 18 electrons. Then N shell is 32 electrons. You can sort out the other ones yourself using that rule. Then how do we now draw the structure of atom or electronic configuration of a particular atom? Let's start from the electronic configuration of helium and lithium. Remember, the atomic number of helium is 2. That's why I wrote it this way. The number of protons is equivalent to the number of electrons. I hope it's not forgotten. So, helium has atomic number 2. That means helium has 2 electrons too. Okay? Then, let's draw the structure of helium. This is the nucleus, and this is the first shell, this is the second shell. Remember, helium has only 2 electrons. Some person will say, okay, if it has 2 electrons, let me put 1 electron in the first shell, then the next electron in the second shell. But this representation is wrong. That's why I marked it bad. Because the first rule says it is that the maximum number of electrons the first shell can take is 2 electrons. So this first shell can also take 1 more electron. And the second rule says that the inner shell must be filled before any electron is taken to the next shell. And this is the first shell, which can take maximum of 2. It just took 1, so it needs 1 more to reach its maximum. Then, you don't need to take this to the second shell when the first shell is not yet filled. So to obey the second rule, you put the first and second electrons in the first shell, in K shell. Since it has only 2 electrons, we are done with the representation because there is no more electron to send in the second shell. Okay? So this is the structure of helium and not this. Then coming to lithium. Lithium has 3 electrons. So we say, okay, let me represent the 3 electrons in the first shell. This is wrong. Reason, because this first shell, the K shell can take maximum of 2 electrons. So if you put 2 electrons here, any other electron moves to the second shell. That is why this is the best representation. This and this is this has taken maximum, then we move this one to the second shell. So the electronic configuration of lithium is 2, 1. 2 in the inner shell and 1 in the outermost shell. Okay, let's solve more examples. The electronic configuration of oxygen. Oxygen has 8 electrons. So the first shell takes 2 electrons, remaining what? Remaining 6. So the second shell will take 6 electrons. That is why we draw 2 electrons. We put 2 electrons here and 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. This is okay because this second shell can take up to 8 electrons maximum. So since we have 6, we fix the 6 at the second shell. So this is oxygen atom. Then coming to sodium. Sodium has 11 electrons. If we put 2 in the first shell, then you have 9. Remember, the second shell can take maximum of 8. You put the 8 in the second shell, remaining 1. Then you transfer the 1 in the third shell. That is why we have 2, 1, 2. Then 8 here, 2, 4, 6, 8 in the second shell. Then the third shell takes 1. We cannot put this 1 here because the second shell can take maximum of 8. Okay? So, electronic configuration of sodium is 2, 8, 1. Coming to argon now, we have, argon has 18 electrons. So the first shell takes 2, remaining 16. The second shell takes 8, which will make it the remaining 8. right? So the third shell can also take more than 8, right? So we take the 8 electrons remaining to the third shell. That's why we have 2 here, 8 in the second shell, and now 8 in the third shell. I hope you understand. Then coming to electronic configuration of calcium. Calcium and potassium, amongst the first 20 elements, the electronic configuration is a little bit confusing for beginners. So look at this. Listen very carefully. Remember, calcium has 20 electrons, we know, because the atomic number is 20. It has 20 protons, and if it has 20 protons, it will have 20 electrons. Now, when we come to the electronic configuration of electrons, how do we distribute these 20 electrons? The first shell takes 2, as we all know. The second shell takes 8, as we know. Then the third shell takes 10. Normally, your mind will say, okay, the third shell will take 10, because the third shell can contain maximum of 18 electrons. I hope you've not forgotten. M shell takes maximum of 18 electrons. So you say, okay, let me take the remaining 10 electrons to the third shell. That is okay. That is why you have this. But this is wrong. Do you know why? Because rule 3, the third rule says the maximum number of electrons that can be accommodated in the outermost orbit or outermost shell is 8. It is true that this third shell can take maximum of 18. So 10 is okay on it. But remember, this third shell is the outermost shell, the last shell. And the third rule says that as long as it is the last shell of any atom, the maximum number of electrons that you can find there is 8. Had it been there is another shell outside, you can put up to 18 here, and then put other remaining electrons outside. But here, we don't have any other electrons. So this is the outermost shell. And the outermost shell, according to rule 3, can take maximum of 8, no matter the atom, because it is the outermost shell. That is why this is wrong. Therefore, what we do is the first shell takes 2, the second shell takes 8, normally, as it should be. The third shell now, since it has more than 8, we put 8 there because we cannot put 10 in the outermost shell. We now put 8, then take the remaining 2 to the outermost shell, okay? Since this is 2, it still obeys rule 3, because rule 3 says that maximum of 8, that means it can take less than, but it cannot take more than 8. That is why this one is wrong, but this is right. So the electronic configuration of calcium is 2882. I hope you understand. Good. Then, I would like you to try your hands on those study questions. And I'm particular about potassium. When solving or writing the electronic configuration of potassium, remember rule 3. Write down the electronic configuration of hydrogen, neon, magnesium, chlorine, and potassium. And let me know what you get as your answer. If you have any question, you ask me. Thank you for listening.